Hey guys, welcome back. So in this video, we're going to be talking about how to create physical visualizations using data visual again as the initial way to create the visualization. And then we're going to use it to export an SVG file and then bring it into a 3D rendering program. We're going to be using Tinkercad today. And then we're going to send this to a 3D printer. So the first thing we want to do is make a chart in data visual. So I've already created this chart. This is showing the rise in global ocean temperatures over the years since 1980 to 2016. So basically what I want to do with this is export it and rotate it in a 360-degree format or maybe 180-degree format, and then just print it out on a 3D printer. So the first thing I want to do is export this. So if you go to Export, SVG for a vector file, just save it to the desktop is fine. And then I am going to go to my desktop, find the SVG, and I'm going to open it with Adobe Illustrator. So basically the only thing that I really care about is the line chart here. So we want to take this, bring it into a 3D rendering program, rotate it in a 3D formation. So it's kind of like just a 360-degree version of the line chart, which then we can send to a 3D printer. So I am going to just take that bit. So with the white arrow, do Control click. That highlights just the line chart. And then I'm going to copy that, create a new document. The letter is fine. And then paste that in here. And let's just change the color. So let's make the outline black. Now let's make the fill black. And then the color for the outline we don't really need. So what I'm going to do next is turn this into more like an area chart. So I'm just going to use the pen tool to add a little base to this. So I'm going to click and come down, come over, and come up to close it. So I basically took that line and then added a couple pen anchor points to the base of it and turned it into an area chart, essentially. So what I want to do with this is then just go to File, Save As, and then I want to save this as a SVG file. And we could just call this line chart or something. And then just save it to the desktop for now. Hit OK. And now that we have an SVG file, SVG files can be uploaded to Tinkercad, which is a 3D rendering program. So we're going to take this SVG file, upload it to Tinkercad, rotate it so it's a 3D format, and then we can send it to a 3D printer. So let's go back to the browser. And the great thing about Tinkercad is that it's actually free to use. It has a web editor, so you can just go to tinkercad.com, create an account, log in, and then start designing 3D renderings in the browser. So once that you're logged in, once you have a free account, then you say Create New Design. And then it gives you this format where you have a working plane where you can put different objects. You can change the view over here. So top, front, sides. You can move that around. You can zoom in and out by pinching the trackpad. There's also some basic shapes that you can just kind of pull in. So if we wanted to have a cylinder, bring that in. And then there's different anchor points where you can increase the size for the height, increase the overall size, the width and height, move this around in space as well. You can add holes to different objects too. So if we wanted to have a hole in the middle of this and make this more of like a donut, you can do this as well. And then select both, and then you can basically group them together or ungroup them. So I'm grouping this together, so this is making a more donut kind of shape thing. So if you look in the top, it's got a hole in it. So Tinkercad is really easy to use. It's very basic, very straightforward. You can make things directly in it using the simple shapes that they offer here. So if you want to do something a little bit more complex, you can upload an STL file, which is a 3D rendering file format. So if you do something in another program, you can still upload it to Tinkercad and play around with it in Tinkercad. But for the purposes of today, the main thing that we want to play around with and upload is an SVG file. So this is a 2D file, 2D vector file that we could then upload to Tinkercad and 3Dify it, essentially. So I'm gonna delete this for now, and then let's go to import. So I'm just gonna show you this as an example, but so you can import SVG files. So let's choose the file, import the line chart, and you can select the artboard or just the art. We just want the art, import it. Okay, so it's massive. It's okay though. And then we could scale this down, bring it to the center. And then it kind of makes it a little 3D already. So if we wanted to like just play around with the thickness of this, we can look at the view differently. So this is our line chart. It's just got some dimension to it now. But that's not really what I'm kind of looking for. I mainly want this to be more of like a 360 degree line chart, or maybe a 180 degree line chart. So I'm gonna delete that. Okay, so if we click on basic shapes, you can scroll down and there's a section called shape generators. So we're gonna click on that. And the one that we're interested in is the SVG Revolver. This is pretty great because you can upload an SVG and then change some parameters to have it revolve in a 360 degree format, or any degree that you want it to be. So it could be 180, it could be 90, it could be 360 degrees. So we have some parameters that we could play around with. So let's click and drag that to the stage, to the workplace. And by default, it just gives you this, this shape. But we can drag a file or choose a file that's an SVG file. So let's just choose a file. And let's choose that line chart. Okay. Well, that's interesting. So brought it in this format. Let's go back and change it so it's in a different format. Let's see. So I'm gonna go back to my Illustrator file. And I'm just gonna rotate this. Okay, then save it. Let's go back to Tinkercad. I'm gonna try this again. That was pretty cool though. If you wanted to do it that way, you can. And then choose a file. And then re-upload that SVG file. Okay, cool. So let's go ahead and make that a little bit bigger so we can see what's going on. All right. So we have our line chart. It's in kind of this 360 three-dimensional format. So we can play around with these parameters. So there's the angle. You can change that. Make it 360. It's going to do the full 360. We could change the inside diameter down to just 1. That's kind of cool. Change the number of sides. Kind of play around with that. So how many sides it has and how smooth it is. So I'm just gonna make it like super smooth, 48 sides. You can play around with the sketch rotation. Oh, so you could play around with the rotation as well in here if you wanted to, and rotating the SVG element. That's kind of cool too. So kind of make like a little bowl or a vase out of this line chart. Set this back to 0. So there's a lot of different parameters that you can play around with this SVG Revolver shape generator. But this is basically what I want to do. So I want to print this out. Let's also do a version that's maybe like 180 degrees. So I'm going to bring this down to 180. And maybe rotate this to there we go. Okay. That's kind of cool, right? This three-dimensionalized line chart going on. Cool. Looks good. So why don't we print that one out, and we could do the 360 one as well. So the next thing we want to do is basically just export this file. So let's go to File, Export. And for my 3D printer, I can send it an STL file. So I'm going to export this as an STL. And let's call this line chart STL. Save it to the desktop. Okay, let's go to the desktop. So now we have our STL file, which we can send to pretty much any 3D printer. So I am using a Prusa i3. So I am going to use the software that came with that to basically slice the layers and get it ready for the 3D printer. So I'm going to open this in the Prusa slicer. Cool. And then it's loaded in to the slicer that came with the 3D printer that I use. You can use whatever slicer that works best for you and the 3D printer you're using. You can play around with these settings. You can change the infill if you want, but I think 20% is probably fine. If this is just going to be like a for display purposes only and not like something that is used and handled, then I think 20% is fine. And then at the bottom it says slice now, so you can go ahead and slice it. And it's creating all the slices for us. And then I'm going to export this G code, and this G code is what I use for the Prusa. I'm going to save it as line chart, space G code. All right. So this is the file, linechart.gcode, that I'm going to be sending to the 3D printer, which will then print out the design that we created based off of a 2D line chart and turn it into a 3D piece of sculpture, physical piece of sculpture. So let's send that to the printer and see how it turns out. So here is the print. It's pretty cool. It's a little rough around the edges, but it's definitely looks like the line chart that we took from Data Visual. So it's three-dimensionalized, it's physical, and it's based off of data, which is cool. I also did another one that didn't work out as well, but this is the 360-degree version of it. And kept the hole in there, but you could obviously fill that if you wanted to. But it's might be a little hard to see, but there is some issues of clarity and crispness around this print. So you got some like things flying off. So you just have to kind of test it out, do some test prints, see what works well. Both of these took about an hour, maybe an hour and a half to print out. And you can tell that they're still pretty small. So it takes time to print these. So if you're doing tests, maybe like reduce the percentage for the infill to speed up the job. But yeah, the 20% seemed pretty good. You probably could knock it down a little bit more if you wanted to. But because of the fineness around the rings, it doesn't look all that perfect. But again, this is just kind of a prototype, and we can use other methods or send it out to get printed for something that's a little bit nicer and made out of nicer material. But this is definitely a good example of how to take a line chart or rotate it and three-dimensionalize it and then print it out on a 3D printer. Cool. So go ahead and have fun with this. You can obviously do other things other than line charts. You can do bar charts. You can do the heights of like states and print out the each state for like a map. You can play around with geographic and topographic visualizations. So you can do a lot with this. So yeah, go forth and have fun with 3D printing and physical data visualizations.